Hello everyone, I'm Abdul Terry from Senior Design 1 here at FIU, and today we will present the second part of our project, which is the safety gate system. In this presentation, we will discuss some of the sections of Proposal 2. In the globalization, the reach of product in the international market will be discussed. In standard consideration, we will discuss the international standards that our project will follow. Feasibility analysis will help in determining that if the project is possible to complete or not. In risk analysis, the risk involved with the project will be identified. The plan of action will guide about the plan to complete the project successfully. Multidisciplinary aspects will discuss about the different skill sets of the team members necessary for the completion of the project. The personnel will include the resume of our team describing their skills and academic strengths. In budget, we will discuss the budget needed to complete the project. In end product description, it discusses the final shape of the product and the other things that will be delivered with the final product. At the end, the conclusion will conclude the presentation. Globalization is when companies or organizations start operating on an international scale. It can also be identified as the increased interconnectedness and interdependence of peoples and countries. Potential customers or consumers will accept or prefer our product in the local market as well as in the world because it's highly required in the society due to the pandemic. Our product is simple and moderately priced, and potential customers will buy it because it fulfills the purpose. We will not face cultural barriers in the Asian countries because of the changing dynamics due to the COVID. We will target India because of the vast population, so that many people have suffered and died from the coronavirus. Following are the standards considered by the project. The first one is IEEE P2817, that is related to the verification of autonomous systems. The second one is ISO 13485, deals with the specification of requirements for the quality management system. The third one is IEC 61230, which ensures the safety, reliability, and durability of the product. The fourth one is IEEE 2700, provides the framework for sensor performance. And for feasibility analysis, I'll call upon my partner.
Feasibility analysis. The following are the feasibilities that will be discussed in this section. First, technical feasibility. Second, financial feasibility, legal feasibility, resource feasibility, market feasibility, cultural feasibility, and at last, schedule feasibility. Next, let's move on to the risk analysis. The table shows the categories and the risk involved against each category. There are two technical risks, which includes device not able to detect temperature from a distance greater than 5 feet and the risk involved with the connectivity loss. The economical risk is related to the budget constraints in the project. The resource risk is related to the unskilled manpower. The market risk might occur due to the emergence of similar product in the market, and the legal risk involves the copyright issues. Next, let's move on to the risk exposure. A risk exposure table, red color shows that the risk is catastrophic. Orange color indicates that the risk is severe. Yellow color shows that the risk is moderate, and green color shows that the risk is low. The market risk 1 lie in the moderate risk category and it's unlikely happen. The technical risk 1 to 2 lie in the catastrophic risk category and it's possible to happen. Economic risk 1 lies in the severe risk and it's possible to happen, and resource risk 1 lie in the low risk category and it's unlikely to happen. Thank you for listening.
Hello, my name is Hamoud Khadi. The table shows the risk mitigation. As you can see here, both the technology risk are catastrophic and they can be removed by using infrared camera for temperature detection, for Wi-Fi, and fast and reliable data transfer. The economics is severe and it can be removed by involving the investors. The rescue risk is low and can be eliminated by giving risk tasks to the right person. The market risks are moderate and it can be mitigated by doing market surveys before launch. And finally, the copyright risk is catastrophic and it can be avoided by quick patenting. So as you can see here, plan of auction. Considering the safety gate system project, the plan of auction will include first the statement of work, work breakdown structure, gain chart, and peer chart, and critical path. So the statement of work includes scope of work, location of work, and period of performance. The work breakdown structure includes 4 phases. First phase 1.1 research, and second phase is 1.2 hardware design, and third phase is 1.3 software design, and finally phase 1.4 prototype testing. Now we will continue with my partner. Thank you.
Hi, my name is Kal El-Dosari. Today I'm going to talk about the Gantt chart. Gantt chart is generated using the Open Workbench software. It can be seen that the total project is divided into 4 phases, and each phase is subdivided into tests. Each phase and test is given an ID. The bars represent the time taken for each task. The red bar shows the dependency of the task on the previous task. It can be seen that the project will complete in 33 weeks till the end of graduation. Bar chart shows us the graphic visualization for the project. The red label path shows the critical path. It can be seen that the project ends on December 27, 2021. Multidisciplinary aspect, Ahmed Fajhan has command over C, C++, Java, Python, and various programming languages, and leads the team. Abdullah Al-Mutairi has command over networks, circuits, and embedded system, and works on system hardware parts. Yusuf Al-Utaibi is proficient in software like Multisim, Proteus, and MATLAB, and worked on system hardware parts along with Abdullah. Humud Al-Khaldi is good at Java, C, C++, and proficient in different software like Proteus, and worked on system software parts and integration with the hardware. Kal El-Dosari is very good with hardware, technologies, and programming. He's great at Python, Java, R, embedded programming, and Visual Studio, and makes testing. Procedures and helps in prototype testing along with other teammates.
Hello everyone, my name is Ahmed Fajhan, and today we'll talk about personnel. This section includes the resume of the team. Getting information about the workforce will help in understanding the capabilities of each team member. The resumes of the complete team are mentioned in the proposal. Budget. The budget includes all the costs of human resources, space, and hardware. It helps in determining the finances before starting the project. Figure shows the budget produced by the Open Workbench software. The resource is defined against each task. The rate per hour is also mentioned. The hardware cost is also added to the list. The total cost of the project is estimated as $573. And the product description shows the complete operational structure of the project, from gathering components to the making of the final prototype. The project has 3 levels for functions and specifications. Level 0, the level 1 of the system, has swing gate feedback, camera, sensor, and communication module. Level 1 of the safety gate system, there are feedback sensor, camera, IR sensor, Wi-Fi module, and swing gate relay. Level 2, the level 1 of the system has Arduino, Raspberry Pi camera, IR temperature sensor, read sensor, relay switch for swing gate. Wi-Fi module for communication. Conclusion. Through our product, we will bring a positive change in the world. This product will help controlling the COVID spread, so as to make our world healthy and virus-free again. Review. The team has successfully analyzed different aspects through Proposal 2. The budget needed to do the project is clear along with the timeline. The team diversity is discussed and tasks are equally divided among the team. The possible risks are identified and their solutions are presented. And the product descriptions has allowed the team to visualize the final shape of the product. The standard identification will help in making the product more reliable. And thank you everyone for listening.